11:25. So probably 45 minutes is okay
Yes, fine.
for you, Vinod?
Yes, I can hear you. Tell me.
Vinod, it's 11:25. Is 12:15 is okay for you?
Yes,
Still?
okay.
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 So thank you for uh, joining, and we will have Vinod started. Thank you.
So, good morning to one and all. So, as Yogesh, thank you, Yogesh, for introducing me. Yogesh is my very old colleague when we were working with Popes Marshall. He is the most enthusiastic guy in our team. Thank you, Yogesh, for your introduction. So, today we are going to talk about connecting the field devices. So, when we are talking about the field devices, so those field devices means I'm talking about the plant, the process plant like pharma, oil and gas, and all these people, the dairies and all this, and connecting these field devices to the cloud, and the improve. How do you improve your plant performance? That is the crux, and we are going to talk about it today. So, in my today's talk, we are going to mainly talk about the challenges the people are facing, like in the plant. So, most of you people are working with the plant people, or many of the people they are the maintenance people or the operations people in the plant, and they are, and your customers might be are facing all these problems which we are mentioned here today. So we have to solve these problems, and how do we use the technology, because you have the instruments in the plant, and those instruments, they have the data, they collect the data, but somehow we are not able to capitalize that data and to do the proper, to build the proper analytics, and to solve all these problems of the people as far as their plant budgets and product quality and plant equipments are concerned. So we are going to talk about today all these plant issues. How do we solve them? So the first thing is, so where to get the data. So why do we need this from the field? Because you, often you're talking about I'm getting 420 milliampere from the instrument, and why do I need any other data from the field? Or because we are in the smart world, and now it is a smart sensing, which gives you a lot of analytics not only the measurement. So we have to see that. Then instruments and process diagnostics, we'll talk more about that in next slide. Then easy connectivity to us, and so that we can take a prompt action once we get some message or some maintenance alert, so that the engineers, plant engineers, should be able to take the prompt action on that. Then you know the problems, and how do we analyze those problems, and you have to troubleshoot those problems, and you get the data, uh, and do perform some analytics somewhere, either in the cloud or in the SCADA or in the on the monitoring systems. And of course, the condition monitoring of your equipments. There are very costly equipments like control valves and dryers and heaters, whatnot. So you have to do the condition monitoring of the equipment. So this is all we have to do as far as plant is concerned. And we have to get the, and there are so many instruments are placed in the plant, like you, for example, you have the magnetic flow meter. So magnetic flow meter gives you all this data on communication platform, but I'm not sure whether people are using this data in their analytics, whether they are using this data to solve the plant problem. So like this, for example, this is ENH flow meter, and this ENH flow meter gives me all this data. There are likewise there are many other flow companies who are having the flow meter. They also give such data. So how do we get this data in the on our device, on our SCADA systems, or on our host systems or cloud-based systems, and you can anticipate the problem, you can work on that problem, and you can avoid the or you can improve the life of the instrument. Similarly, we have The vortex flow meter. The vortex flow meter gives you all this kind of analysis which your problem when especially in the area of the steam flow measurement, especially in the area of the vibration, you get a bad flow rate, the bad totalizer readings. How do we track that and how do you measure that and how to work on this problem? So all this the vortex flow meter, for example, gives all these issues on your communication platform and how do we get that and how do we analyze that? So that is another thing which, for example, suppose control wall. Control wall is a very costly asset, and it works with it comes with the wall positioner. So it gives you the leakage in the wall, faulty feedback, improper control of the control system happens. Suppose then you can see the number of time wall direction changes. What is your wall positioning time, so that you can tune your PID loops. You can work on your adaptive control systems. You can work on set point tracking systems. All those things you can work on, and you can you can have the proper control system and you can improve the product quality against that. Apart from that is service air quality. When I was working with Post Marshall 10 years back, maybe I'm working on this product, the Post Marshall's wall positioner. I used to think about we are doing all these things with our team. We are giving all these analytics on hard or on the field bus. But customer is going to use this. Customer is going to use the leakage. You can estimate the leakage uh, and um, and take action on that. So this is all available on the heart on many of the wall positioner, not only the smart which I'm talking about. Many of the the wall positioner has this data, and how to use this data for your for plugging your leakages. That is very important to have it. So we'll talk about this, how these technologies. So now all these technologies, you in these technologies, you either have the hard or wireless hard or the field bus technologies. So these are basically these are available in the instrument, and you can directly get the data from the instrument, and you can take the action on that, and you can build a complete cloud-based instrument management system, or you can do the complete cloud-based plant maintenance system, and by using all this data, and you can have the effective plant performance by by effectively using these protocols. So why do you need hard? As I told you, because basically it is intrinsically safe technology. It gives you the instruments and process diagnostics. It gives you the sensor and wall diagnostic. You can do the online calibration by sitting into the room. It gives you the multiple parameters. It gives the instrument view from the control room. All those things are there. But apart from that, don't need to lay extra cable, because you know in the process plan there are so many cables are already laid. So our technology is working on the standard 420 milliampere loop. You can it works on the standard um, standard for existing cable which you already laid for your getting a data to your PLCs. So this is a technology which is normally available in the plant at no extra cost. That is one of the better advantage of this technology. Or I understand for the filters you need a greenfield installation, you need a separate cabling and all, but for hard that is not required. Okay, wireless hard also can be used for the predictive maintenance technologies and all. That's a very latest technology available, but you don't need cabling for that. So I'm not going to in detail with the hard technology, the time constraint, because basically all of you know the heart is the bell to zero to frequency shifting technology, which is superimposed on the digital communication, and it is superimposed on the normal 420 milliampere load. This is your 420 milliampere signal, and this heart signal is superimposed on the existing 420 milliampere cable, so that you can tap that signal. So that's how. So basically, this technology is, as we discussed, that it is basically used in process measurement, and the condition monitoring. Plus, it is simple and reliable to use. It is highly interoperable between the wireless and wireless HUD devices. For the wireless HUD technology, it has a predictable latency too, because it is work on the advanced TDMA technology. We'll talk about that. Plus, it is ATEX design is possible because you can use this technology in explosion-proof area. It has a support of device description and FDI technology. So many benefits are available so that customer can use this without having any glitches in their plan, in their existing plant network. We'll talk about little about the wireless HUD. Wireless HUD basically works on the 2.4 gigahertz technology. It's a ISM band, yeah, and it has a 16 channels. It can give you the strength of 8 to 10 dBm around. It works with the 60 meters with internal antenna and 250 to 300 meters with the external antenna. So somehow you can connect it to the gateways using the access point and then network manager, all those part of the wireless HUD network, and you can get a data on the Ethernet. You Ethernet either on the hard IP or the Modbus IP using the hard gateways. So it uses the TDMA technology. What is this TDMA technology? It's a time division multiple access. That means all the nodes are in the plant are having the fixed time slot given, so that no other node shall wake up and talk to each other. Because at one point of time, there's only one node and one network manager are in communication, so that the time is given only to that node, and that's how all the nodes are connected to the network manager, and it gives you the very effective uh, low latency network. So that that ensures you that you get a data after every say 2 seconds or 3 seconds at a very correct time interval, so that you can have the predictable latency in that. It has a different modes of communication like one-way publishing and data bursting, spontaneous notification when the alarm comes, if some any problem comes, it gives you the spontaneous notification. Plus, network manager can also send a ad hoc request and you get a response on some specific packages. Plus, it also has the special feature of auto segmented block transfer. Suppose you have the vibration sensor, and vibration sensor want to send a data of say 16,000 the points once in a shift. So you can do that automatic block transfer using this data set. So such kind of a special features are also available in the wireless HART. Of course, the network and data security is also important, as it has a channel hopping, uh, multiple level of security keys, indication of failed access. All those points are available. All those the latest security features are available on the for the network security. As far as data security concern, it has an advanced encryption standard. Advanced encryption standard of 228-bit encryption is available with you. Every message has a unique encryption key, and that's how it is rotating the encryption keys while joining the network, while connecting the network. All those advanced cyber security features are available with the wireless HART, so that the network uh, get secure. So, as you can see, it is a very key to the digital transformation. Our technology, basically HART and wireless HART, it is a very key to the digital transformation. That's what we are talking about. That how you have all the field devices are connected, and those field devices you giving you the very advanced data which is required. Uh, advanced diagnostic data is required for your plant measurement and plant diagnostics. So we also talk about some of the key applications today, like tank farm management and wall diagnostics and condition monitoring, like steam trap monitoring and all. So in our session today. So when you talk about the heart, it is basically the say the subsets of different types of commands. So you have the universal command, which is mandatory for each device to implement. You get in that you get the basic information of the device. Then you get multiple variable of the data. Suppose you have the mass flow meter. The mass flow meter has the flow rate, the totalizers, and the temperature or pressure. All the mass flow or volumetric flow, all the multiple variable information is available on hard. Plus, you get all the sensor information of your sensor, instrument tag, description, everything which is required for the instrument management, alarms and diagnostics, all those things. And apart from that, if somebody changes some configuration in the device, you get a configuration alert so that you can call up that command and you can upload the configuration onto the cloud or onto the on your host systems. Different common practice command for setting the ranges and calibrations and device reset are also possible. Plus, there are different special commands for the special devices, like you have the control wall, or you have the flow totalizers. All those special commands are also available for the special devices. So this is the basic hard command summary is available. So plus you also have to do the hard registration. All the devices which are connected there are having the are registered with the hard communication. Plus those devices are tested for all impedance, signal levels, noise tolerances, EMI and UNC. So all these instruments which are connected into the plant are having the reliable communication, hard communication with your plant network. So that's how the hard network is evolved in last 30 years. So connecting the hard devices onto your devices or connecting you to the cloud. So you already have the 420 milliampere network, which is connected to your PLC and DCS and SCADA systems. So you can use the hard gateways, connect to your connect to your devices, and now the gateways are also available by which you don't need to. You can have the single gateway. You can have in which you can have the multiple 420 milliampere loops, and you don't need to park your current to 4 milliampere or 20 milliampere in a single loop. So you can get a 420 milliampere to your PLC or DCS. Plus, you get all the hard data from which is superimposed on the 420 milliampere network using hard gateway, and which can be connected to the cloud gateways which are readily available in the market from Cisco or others. So from Modbus to we can connect those to Modbus to cloud. So this is how you can connect to your basic instrument to to the cloud by using the hard gateways and can those hard gateways can be configured and installed in the control panels where you are terminating your 220 milliampere signals. Or you can also those can be implemented either in the junction boxes, and from there you can connect it to the cloud gateways using using the data from the Modbus, and you can configure that way. So once you connect it to the cloud and you have the data onto the cloud, the most important part is the cyber security. The cyber security layer which you need to have. ISA is doing a lot of work on the cyber security. They have the standards like ISA 62443. We have the in ISA lot of training programs in the ISA cyber security is concerned. So now here all the cloud people need to implement a TLS 1.2 or 1.3 standard into their gateways, into their cloud. Then you have to have this SSL certification, standard security layer certification, where you can get a security certificate from the standard vendors, and you can have the cyber security the connected devices, your gateways to the cloud platform. There are many multiple cloud platform available from different companies, and those are offering this solution. Or you can build your cloud platform uh, using all these technology which are mentioned here. Plus, of course, you have to have the multi-activity broker or the OPC your client to get the data onto the cloud from the gateways. Then you have the standard databases, common databases to address the influx of data, very high influx of data from from the field onto the cloud. So this data you are getting, which is then used for the analytics. But to store this data, you need a simple non-SQL databases like MongoDB or InfluxDBs, and these databases are being employed into the cloud, and then on that data you can perform the analytics. You can use the visualization tools such as Power BI and all, and you can see all the visualization of the data and analytic data. Plus, whatever data you are getting, you can perform the analytics based on your plant needs. There are many analytic experts are available in different. You can build your if you're a plant expert in your chemical process and all. You can build your own analytics using the Python. Plus, you can use the SQL or graph databases to store all this analytic data and you perform that analytics. All those things you can do onto the cloud, and yeah, and you can perform the better analytics onto the platform, any of the cloud platform or on the server platform. So let's talk about some of the IoT applications using HART. We will talk about the tank farm management, wall positioners, stream track monitoring, gas leak detection, and all. When you have the tank farm management, so basically there are many tank farms are situated remotely. So you have to do the remote management of your tank farm so that you can protect your tank farms from thieves or the tampering attempts. There are leak detection systems are available. You can do the structural integrity control. You can you can improve your production planning if you have a proper level monitoring of your plants, of your all your tank farm. All those things you can do because based on the tank level data, suppose you have the tank gauges of say the solid tank gauges are available say from the Vega or Corona. These are the advanced tank gauges which not only gives you that level data, but they also give you the data by which you can build analytics against the threats and tampering attempts. Plus, you can also build analytics for the leak detection or structural integrity. Plus, of course, you can do the better production planning when you have the proper inventory of all your the chemicals and solids in the tank. So this is one of the very good application which you can build using the hard technology as far as digital transformation of your plants is concerned. Another is the wall positioning. As you know, those controlled walls are a very costly asset. Plus, control walls are employed in the plant which are actually controlling the processes. So you have the PID controller and everything, but actual control is taken place in the control wall. So what should be the control quality? Your control quality, it gives you the quality of your process, quality of your entire product, or quality. We can also you can also control the energy consumption of your plant properly if you have the proper control wall and proper control on your process. So you can you get using the wall positioner, which gives you a lot of data apart from your we are setting the say wall set point, plus you are also getting the feedback from the actual wall position. You can get a much more data or much more insight into the control wall, so that you can perform. For example, you can control the damping. You get a damping data. You get a data for the number of changes in the direction, the rate of change of direction into the plant. So that means how fast your control is, or how suppose you want to have the proper steady state control. Then how do you set your PID parameters for your number if the changes in the direction is very fast? What is your wall operation total time? So that you can set all the control wall service air pressure, or if you want to have the amplification in the service air, if you want to do that operation time, it gives you the proper control. That is also very, very important. And most important thing is that the hard technology can give you the leakage in the control wall. When you control set the wall is tight leakage, it sets its position, it saves its position, and when you tight it again, and when you try after say 6 months or a year, you can see that there is some changes in the wall C, and how much vena contracta is formed, and how much leakage is forming into the wall seat. And using the Bernoulli's theorem, uh, the you can estimate the leakage in the wall, because this is a continuous leakage, and if you have the very costly solution which is flowing to the control wall, and that gives a lot of savings into the into your plant, and of course it improves your quality too. So this is a very important application of using the wall positioner, using the data from available on the control wall on hard communication platform, and you can do a lot of predictive maintenance activities, and you can build your application. This is for all your system integrators. This is for end users. So our system integrator, they can give the good lot of value to their customer by creating such applications, and they can excel in this technology. Next is the sleep trap monitoring. Actually, these now the non-intrusive sensors are available to monitor the trap, the faults in the steam traps. You can detect the steam leak so that you can save the energy. You can detect the water logging condition to of the steam trap so that it should avoid the production loss. Apart from that, the UNFCCC guidelines are available to calculate the steam loss, so that if the wall is leaking, how much steam loss is there, you can actually calculate that, and we can give you the any kind of one can get the overall plant status, plant steam loss, monetary loss. Those such systems are available in the market. You can apply analytics to it. You can predict whether which type of trap is leaking, whether it is a rapid cycling into the steam trap, or whether there is a blow through condition in the steam trap. All those things you can predict using the hard technology, the way you are getting the data. Another important application is the gas leak detection. So you can see in any process plant there are so many safety walls are there. So these safety walls are on once in a lifetime, maybe when there is an alarming condition. In that you have the safety wall door gets open. But the problem with the safety wall is that there is a leak in the safety wall, and there is a continuous leakage through the safety wall, and you are losing either your heat or other your very costly fluid which is passing through that line. So you can monitor the leak of this safety wall using this technology, and you can save a lot by plugging all these leakages, and you can save a lot on your plant running cost. So that's how. So if you summarize all these applications, that the main important thing is here that we have to receive the relevant data from the analytics, which is a key to solve your customer's problem. This is the very key things in getting the data, which you are getting your plan preferred instruments, which is normally not a practice in the standard process plan, which gives a lot of data all your apart from all your 420 milliampere signal, or you are doing the Bluetooth libraries and all those things. But this data is very important. So why HART and wireless HART technology helps in getting a data on without any extra cabling, without any extra cabling cost or adding any extra burden to the existing infrastructure into the trading. So using this diagnostics available in this instrument, one can improve the control system quality as we discussed, so that improvement is there in the process quality. So then you can improve the plant performance operations by getting the regular maintenance alerts. Plus, you can get the predictive maintenance of your instruments and wall, especially wall, and extend their wall lives. It will save your plant maintenance costs. All those things costs you can control, and you can improve your plant maintenance budget of your customers. That's how it is. So this is what all I wanted to talk about the data which is there available into the plant and instrument, and using the hard technology, and you can get the data and you can connect that data to the cloud, and you can do the wonders by using this. That's what I wanted to tell you. So about us, we are Intellect Process Solutions. We are embedded systems company in automation protocols. We have started our operations in 21. We work with Adobe Powertron, Thermax, Commercial, Adobe Fluidine, Radio Electronics, or many other partners. We are working with all these people. Then we also have our own product ranges, which is basically the gateways, the protocol gateways. We have the hard gateways, backnet gateways, Modbus TCP gateways, Ethernet IP, Profinet gateways. Plus, we also work with many OEMs, means instrument manufacturer, and give them the communication solution by adding a small communication plug, like hard plug, or backnet plug, or Ethernet IP plug, into their devices, and we give these communication solutions too. That's what I wanted to tell you. I think I have completed in 40 minutes. Thank you. So let's open for the question and answer. Yogesh?
Yeah, so thank you, Vinod. So members can ask their questions, any doubts. So you can keep sharing the screen.
Yeah, Satish is asking a question.
Yeah, you can no, Vinod, you can keep sharing the screen so that you can refer it again.
Okay, okay, I will do it.
So
Once you share, I'll ask you.
yeah, Nilesh has a question. While selecting gateway, any particular system compatible to be check like version of software? You can read that question in the chart.
Okay, I'll just go through that.
While selecting gateway, any particular system compatibility. So some compatibility with the version of the software or whatever.
Yeah. So all these hard gateways are normally works with both hard 5 and hard 7. Hard 5, hard 6, hard 7 version. When the hard communication standard is evolved in such a way that it becomes backward compatible with all the instruments, because most of these gateways are also working with the instrument which are installed in 90s, and you can get the data of hard version 5, and only thing that if they might not be having the best kind of analytics available in their hard communication platform, But as I told you, many of the latest instruments which you have, we talked about like ENH flow meter, Volkswagen's control wall, wall positioner. These kind of instruments are now which are there in the market. Those are came up with the hard version 7. And these people are having all these analytics. So the upward compatibility is managed in better way in hard technology as far as hard technology is concerned. So plus when you use the hard gateways, now the gateways are available with the you don't need to park a current of 420 milliampere. So you can get a you can no need to disturb your existing 420 milliampere, and you can still use the hard gateways can connect to the cloud using the and you can get analytics easily. But the basic problem of the plant people is that they don't want to uh, touch their existing plant DCS or SCADA because it's very risky for them for their plant operation. So these gateways can be connected to the plant without disturbing their community members.
Satish has a question, and then we have Adarsh question after that.
So, thank you, Vinod, for such a wonderful presentation. Very basic question on the same slide what you are sharing right now. So, let us assume that there is no hard gateway and there is no Modbus and cloud gateway to start with. And the lower half side is there. The 4 to 20 milliamp PLC SCADA is existing.
Yeah.
Okay. And then somebody wants to add the hard gateway and add the cloud gateway as well. Right. So there is a tapping shown from the existing 4 to 20 milliamp loop to the hard gateway.
Yes.
So practically how to go about it?
See, the hard gateway has a internal registers, for internal current sensing registers. So the 420 milliampere, uh, you have to route your the 20 milliampere line through these registers, and it doesn't affect your 420 milliampere loop. And the hard signal is available across that 250 ohm resistor, which is already there in the hard gateways.
Okay. So this 4 to 20 milliamp is a current loop, right? So you
Yes.
physically have to break that loop and take it through the hard gateway?
No, only it gets the 250 ohm resistance get added into the loop. Okay, you may have to
Added
break
into
it
the
for
loop.
for a moment, just for connecting it. But
Yeah, only for
just
the
putting this.
connection, initially you will
Ah,
have to break and add that resistance in the loop, right? Hard resistor.
yes, but doesn't it, but it doesn't affect your 420 milliampere current
That's fine.
signal.
That's fine.
Yeah.
But initially one break is required to add it in the loop, take it in the series, and then you can continue.
Yes. Yes. So you can add a small resistance into it, and then across that you get a hard signal, and
Okay.
and hard gateway employs that uses that hard signal, and sends the commands and response on that 420 milliampere load. So no need to change anything into your processes.
That's right. And once you have the hard gateway, adding on to the Modbus, any additional efforts are to be taken, how to go about that? Because that is the core of today's session or seminar.
Yes. Yes. So now, so it depends on the what kind of analytics you want to build.
Yeah.
Because you get a lot of data on the Modbus from the hard gateway. So it plus you can also build because of course it gives you all the data available in the universal commands. So all those universal command data, like you have the tag, description, everything, you can also get all the alarms and the diagnostic messages which are there in your cloud gateway.
Okay.
So we have a question from Adarsh on the chat. Want
Yeah.
to create IoT SCADA and
So,
my
Yogesh, I cannot
PLCs.
read the chat somehow. Can you just read
Yeah,
it?
yeah, I'll read it out. Want to create IoT SCADA connected to PC Ethernet. How can I create IoT SCADA? You want to repeat it? So I'll repeat. Want to create IoT SCADA and my PLC is connected to PC Ethernet. How can I create IoT SCADA? I think it's something to do with how can I connect HART gateway if IoT the Ethernet port is already
So what
booked.
there is, the question is, I, I presume that he want to have the IoT SCADA means he want to connect it to the cloud, and you can connect it to the existing the existing data. You want to connect whatever data is available onto his local system, and you want to connect it to the web-based SCADA. So if it is if he has the existing SCADA in place with him, then we can use the OPC server, and using the OPC server, he can send the data to the cloud directly. Or you can use the cloud gateways. You can
Okay.
have the, and that can be connected to uh, uh, using the Modbus. You can connect it to the cloud directly.
We have
Now,
Sandeep, you can go ahead. Sandeep Zordar, if I'm not mistaken with the surname. Sandeep,
Uh,
take the.
am I audible?
Yes.
yes,
Am,
you're
am I
right.
audible?
Yes.
Sir, I had a question. We have all these features that you're speaking about in our heart management station that is connected to the DCS. So, what other benefits do we get when we connect these to our, through the heart gateway to the cloud? What is the advantage
No,
and the
no,
disadvantage in both scenarios?
suppose, no, nothing. So, only the price benefit. So, when you have the system, the PLC scanner or the DCS system, which has a heart enabled IOs, okay? So, those heart enabled IOs are getting, you are getting all the data in your instrument management systems or the asset management platform. So only thing people, what we have seen that people are not using that data judiciously. That is the purpose of this session. Is there? So that data is available in the asset management, and how do you use that data? We have seen 2 3 applications, and how do you use that data to solve our plant problems? That is the key of this session today. So there is no only thing you if you use the hard gateways directly, you have a little what you call little more the cost benefit, and you don't, or if you don't have the hard enabled gateway in your business process plan, you don't have to invest in that. You can use it without doing without making any additional changes in your plan. You can just employ this and connect it into your panel to your key process parameters.
Sir, I have a second question, sir. Sir, you are speaking
Ah,
about the TFMS, sir, Tank Farm Management System. So,
ah,
sir, regarding that, sir, that involves custody transfer. And,
yes.
sir, in India, do we have any installation where we have tank gauging system fully based on wireless heart?
We are, I think, Reliance Hajira, which was earlier IPCL, they have this information.
Okay, okay, thank you, sir.
That's why it was IPCL, they have this information.
Ravindra, you can ask the question directly. We have 2 questions, so you can directly ask the question instead of I reading it. Ravindra? Ravindra, are you there?
Yeah. Use cloud gateway for safety PLC. Is it recommended
Yeah.
or accepted? So I'm not an expert in safety. I'm just answering the Pramod Parikh's question that can we use the cloud gateway for safety PLCs? I don't think so because SIS is a different standard and we cannot use it for the safety PLCs, especially wireless HART. So that is not the case.
Pramod has raised his hand.
Yeah, thank you, sir, for this important session. Am I audible to you, sir?
Yes.
Yeah. In your hard gateway, basically for communication between the field devices and to that of the server or client, how will you trying to improve the latency?
Yes. So wireless HART gives you the improved latency. And normally, in every application, what we are talking about, when you have the wired HART application, wire HART application basically is not used for the measurement of or control purpose or control purpose. Wireless HART, yes. The TDMA technology gives you the predictable latency. The technology itself is the main feature of the TDMA technology that it has a predictable latency. And for the wired HART, you have the continuous either you have you are working into the query response format where you have the suppose you have the 4 devices connected and each you are getting the data every 500 millisecond or 750 millisecond and that you can get at the predictable latency. But latency is not important as far as wired HART is concerned because this is not used in the control. 420 milliampere is signal is used in the control and signal is used in the control and all the data which is used to build the analytics and to understand the system instrument diagnostics and other faults, the HART technology is being used for that. So the latency is not very important in this application. Yes, for wireless HART, there's a TDMA and a latency, it has a predictable latency.
Yeah, great, sir. Thank you. Thank you. Thank you, sir.
So Ravindra wants to know that is it a one-way communication or we can send is it two-way communication or
Yeah,
one-way
so it is
communication
basically
directly to the sensor or some
you
PLC?
can have the two-way communications, but the existing system doesn't have the two-way communication. Currently, it has only one-way communications now. So you can have you have to build that advanced systems. So basically, the hard gateways can have the two-way communication, but getting the data from cloud and then transferring it to the cloud to the hard gateways, it has a latency issues. So it is not very easy to do the two-way communication from cloud to the plant devices. Of course, you can do the calibration using your the SCADA systems, or you can connect the local devices, PC-based devices to the hard gateway, and you can perform the calibration of the current loop. But you have to build it with this expert system onto the cloud so that this can be done. But these hard gateways are capable enough to do the basic things like the loop calibration or the getting the setting the configuration counter and all that you can do with this.
So once maybe the last question we can take it. There are some concerns regarding the cyber security if we use HART or Modbus to connect to the cloud. So your
Yes. So hard network is
comments on it.
basically is not exposed to the hard network is and the data from the hard and the data on the hard gateway is not exposed to the public network because basically it works on the 420 milliampere lines and it has a different kind of physical layer. So it is not connected to any Ethernet or any other protocol network, which are prone to the cybersecurity attacks. But when you get a data from the Modbus and when you are connecting it to the communication gateways, then in that thing, you have to have the cyber security layer here. uh, Means all the communication gateways which are normally available in Modbus to the cloud. So these gateways are should have the at least TLS security 1.2 or 1.3 standard. You must have the SSL certification on those gateways to send the data onto the public network uh, on the internet, and then it can be accessed by the
So
cloud
last is,
platform. Yeah.
so one last question quickly from Kuldeep Jain is that once the data is on from the coming from the field to the cloud, are there any analytical options of heart, or it's that we can generate report or do some dashboards from that?
Yes, it's up to you. It's up to the system integrator, or it's up to the end user that how he employs himself, how and how to he generates the report, how to get his data from the analytics. And for example, we talked about the stream trap monitoring. So platform. So this stream trap monitoring platform, you can do the overall plan status or stream loss calculation. Based on that, how much monetary loss you have doing with the loss in the all these stream traps, all those things you can do. So then suppose on that basis you can which how many trap which makeup trap are
So no,
failing.
that will be a third party application. So it will not be the heart applications.
Yeah. So but you are getting the data on Heart
Yes.
network. Right.
Yes.
So on
Yes.
that basis, you are building the analytics. It's up to you the what level of analytics you can do.
Yes. So that was the last question, and I hope all the questions are answered. And um, I hope if anyone wants to contact Vinod, he's easily available on ISA and his company. So I may take your permission, Vinod, to end
Yeah,
this session.
I think there are some people also have some questions. I can see in this chat now.
Yeah,
Well,
and
hard
these are
gateway takes
all taken
420
up.
milliampere or 5 DC.
Yeah,
So it takes 420 milliampere. Yeah, I'm just answering the Abdullah's question.
yeah, yeah. Yeah, that you mentioned in one of the points, so I didn't
Yeah,
take it. But
yeah,
the rest of the questions
yeah. So
have been taken. So,
yeah,
so, uh, so barring the glitch which we had in the morning at the start, so apologize for that again, and thank you all for attending this tech talk, which happens every month, and we have a lot of participations in every tech talk. A lot of question answer session is also very interactive, and thank you very clear and crisp presentation which helped us to understand how the heart can be used in the latest technology which is connecting to cloud, and how it is useful to make the analytics and diagnostics of how is the plant running and what are the conditions in the plant. That will help solve a lot of issues quickly, and for this most of the system integrators. So thank you very much for the session, and thank you all for attending, especially on a rainy weekend. So I will look forward all who are not been a part of ISA to join ISA using isa.org/join. So members are welcome to join the ISA, and you can get along with a lot of tech talks like this and conferences, and also quarterly and monthly publications. Thank you again. Thanks a lot, Vinod. Thank you, team. Thank you, members.
thank you,
Yeah,
thank you, Isaac, for
sure.
giving this opportunity.
Thanks, Vinodji, for the excellent session and good host by Yogesh. See you all in the next talk. Bye bye.
Thank you.
Thank you. Bye.